Hi, this is a video to help you through the activity on isotopes and atomic mass. First, let's talk about atoms. On this slide, there's a cartoon of an atom, and the atom is made up of nuclear particles. In the very center is the nucleus, and the nucleus is made up of protons, which I've represented by these little blue balls with positive charge, and neutrons, which I've represented with little pink balls. These are nuclear particles, and they make up the heaviest part of an atom. The nucleus in general is positively charged because the protons are positively charged. That's why the little proton cartoons have a little positive charge on them. The neutrons are neutral, just like the name makes it sound. So overall, the nucleus has a positive charge. Outside of the nucleus, there is a cloud of electrons. And there are exactly the same number of electrons in a neutral atom as there are protons. And this is so that the atom overall has a neutral charge. So every one of the negatively charged electrons cancels out the charge from the proton. And I've represented these little electrons as they look kind of like little comets in my cartoon. And I've tried to show that each one of them has a little negative charge. And you probably have seen the planetary model of the electrons, which shows them orbiting the nucleus. But that's not really what they do. They're actually buzzing around the nucleus so fast that they kind of look like a cloud. And the way that I imagine this or one way you can imagine this is think about a little bee buzzing around the nucleus, but it's going so fast that it's just a blur, and you can't really see the bee, you just see a cloud where the bee is buzzing around. And that's kind of what we mean when we say it's an electron cloud. It's just the space that the electrons are occupying while they're buzzing around the nucleus. So once again, the nucleus has protons and neutrons. The protons are positively charged, and they make the nucleus overall positive. And the electrons have a negative charge. There are exactly the same number of electrons in an atom as there are protons, so that the atom has no charge at all. So things you want to know about this are, in a neutral atom, there are the same number of electrons as there are protons, and that's what makes it neutral, because electrons are negative, protons are positive, and the charge from each of these two things cancels. The other thing that's really important to know is that the nucleus is the heaviest part of the atom. The electrons are almost weightless. So just like clouds in the sky are almost weightless, electron clouds are almost weightless. And so the entire mass of an atom comes from the protons and the neutrons. So these are the things that contribute to the weight or the mass of any atom. We're going to use these two important pieces of information to understand some things about atoms and the periodic table. So keep these two things in mind. The entire mass of the atom comes from protons and neutrons, and that in a neutral atom, the number of electrons are equal to the number of protons. Here's your periodic table. And notice that each one of the element symbols is accompanied by two different numbers. Let's zoom in on the carbon symbol. So here we have the symbol for carbon, C, and we have two numbers. The number 6 up here is the atomic number, and the number here, 12.1, is the average mass of a carbon atom. The atomic number of any of these symbols tells you exactly how many protons there are in the element. And if it's an atom, it means that this is also the number of electrons. So we could say that in a carbon atom, we have 6 electrons and 6 protons. And that leaves us with the question of how many neutrons do we have in a carbon atom. So you can tell right from the atomic symbol how many electrons and protons something has. This technically means the number of protons. And then we're going to figure out how to determine the number of neutrons in a minute. But notice that hydrogen has 1 proton and 1 electron. Helium has 2 protons and 2 electrons. And you can read the number of protons and electrons on any of the neutral atoms. this number, the atomic symbol, or excuse me, the atomic number means the number of protons. But in any atom, because there are the same number of protons and electrons, you'll have the same, you can just read this off the periodic table. Okay. So here we have the atomic number, and that tells you the number of protons in any element. It also means the number of electrons in a neutral atom. This number here is called the atomic average mass, and we're going to talk a little bit about that in your in-class activity. But it's the average mass of carbon atoms. The fact is that there are actually 3 different versions of carbon atoms. And this is the symbol that's used to represent isotopes. The notation for isotopes is this. Now, notice that this can be confusing because over here, the number 6 is the atomic number, and it's on the top of the element symbol in most cases. And when you're using notation for isotopes, that number goes down here, and it's called Z. So I would put a 6 here, just like this one, if I was talking about carbon. So this number goes from the top of the symbol in the periodic table, and it ends up as a subscript on the notation for isotopes. But that's the same thing. And the superscript here on the symbol is not the same as the average atomic mass. It's actually the mass number, which is the exact mass of that atom or that isotope. And this number comes from the number of protons plus the number of neutrons. Each proton and each neutron weighs 1 atomic mass unit. And so here you can see that this carbon has 12 nuclear particles, or it has a total number of 12 when you add the protons to the neutrons. And we can see that it has 6 protons. And so if you want to figure out the number of neutrons, you just need to subtract this number on the bottom from this number on the top, and that gives you the number of neutrons. So here we have 3 different isotopes of carbon. An isotope are atoms that have the same number of protons, which makes them the same element. They have the same number of protons, but they have different number of neutrons. So remember, the things that we're talking about here are the things in the nucleus. The protons are actually what define the elements. So carbon will always have 6 protons, and hydrogen will always have 1 proton. But the number of neutrons in the nucleus can change, or it can vary from atom to atom. And here we've got 3 different versions of carbon. All of them have the same number of protons, but different numbers of neutrons. Remember that the entire mass of the atom comes from protons and neutrons. So if you have the exact mass of the atom here, you can subtract the number of protons from that mass and get the number of neutrons. So this carbon atom has 6 protons and 6 neutrons. This carbon atom has 6 protons and 7 neutrons. And this carbon atom has 6 protons and 8 neutrons. These 3 different types of carbon are isotopes. They're atoms that have the same number of protons but different number of neutrons, or different mass number. And the atomic average mass is the average between the natural occurrence of these isotopes. So you can tell from this number which one of the isotopes is the most common. So there must be a lot more 12 if the average number here is very close to 12. To illustrate this, do the activity called Distinguishing Mass Number and Atomic Mass, which is basically asking you to write down the ages of the people in your groups and then find the average. It's very similar to this. So this, like 12 would be an age, 13 would be an age, and 14 would be an age of 3 different people in your group. And if you use the data from the entire class, you'll see that there are some ages that are much more common than others. And then the average, you'll find that the average is closest to the age in your class that's most common. Just like this average is closest to the isotope that's most common. Carbon-12 is the most common isotope. Again, we'll talk about that in just a minute. But first I want to talk about, what if your atom is not an atom? What if it's not a neutral atom? What if it's something else? If it's not neutral, then it's called an ion. Let's look at some examples. What if you have something that has 3 protons, 1 neutron, and 2 electrons? All right, look at your periodic table and find the number 3. Anything that has 3 protons is going to be a lithium. So we could write lithium here, and that's what we're talking about. And same thing here, because this one also has 3 protons. And if it has 3 protons, we can also write the little number 3 down there for the isotope symbol. And now if it has 1 neutron, that means the number up here should be 3 plus 1 is 4. So we'll put a 4 for both of these. Now, on the top here, we've got something that has 2 electrons. And if it has 2 electrons, that means it has 1 more proton than electrons. Remember that the protons are positive, so if it has 1 more positive charge than negative charges, this symbol needs to show that. And you simply show that by putting a +1 as a superscript on the right-hand side of the symbol. So this is the symbol for what I've written up here. You have 1 more proton than electron. That means you have 1 extra positive charge, and you'll put a +1 here. Down here, we have 5 electrons, and that means that there are 2 extra electrons compared to the number of protons. So that means there's 2 more negative charges than there are positive charges. So we'll want to represent that here. The overall charge of this ion would be -2. So if you'd like, you could pause the video now and try to work through your activity. Try to work through at least the first 2 pages and read the material that's on the 3rd page that's relevant to the average atomic mass. You want to have a conceptual understanding for the average atomic mass compared to the mass number of an element. And you also want to be able to understand what goes into a symbol like this. So practice, and then we can go on. I want to explain a little bit about number 5, which is on the 3rd page of your activity, just in case you don't understand on your own. So there are 3 isotopes of carbon, as we said earlier, and this is the elemental symbol from the periodic table for carbon. Again, notice that this number is not exactly the same as any of these numbers. Your activity gives you the information that there are approximately 9,899 carbon-12 atoms. There are about 100 carbon-13 atoms here, and there's about 1 carbon-14 atom. So you can see that carbon-14 is the most rare kind of carbon atom, or the rarest isotope of carbon, and that carbon-12 is the most common isotope of carbon. Problem number 5 asks you to find the percentage of atoms that are carbon-12. And so you can do this simply by using what you understand about percents. You would take 9,899 divided by, so this is part, divided by the whole, which is all of the carbon atoms that are being discussed, and multiply by 100. And you should get that 98.99% of carbon atoms are carbon-12. To calculate the percentage of carbon-13, you do the same thing. And you should get that there are about 1% of carbon atoms that are carbon-13. And carbon-14 is only about 0.1% of all carbon atoms. All right, so let's talk about where this average mass number comes from. So I'd like to use this information from the activity to show you where the average atomic mass really comes from. I'm going to use these numbers. Now, if I wanted to take the average of the average mass of these 10,000 carbon atoms, I know that 9,899 have a mass of 12, 100 have a mass of 13, and only 1 has a mass of 14. I can add all these numbers together, divide by 10,000 to get the average. So that's what I'm going to do. I'm going to multiply the mass of 12 times this many carbon-12 atoms. I'm going to multiply the mass of 13 by that many carbon-13 atoms, and I'm going to multiply the mass of 14 by that many carbon-14 atoms, divide by 1,000 atoms, and I get the average mass of all of these 10,000 atoms. So this average mass is what you see in the periodic table. There is no one carbon atom that actually has this mass. This is the average of all of the naturally occurring carbon. And this is true for any element on the periodic table. The mass that you see is an average of the naturally occurring isotopes, and it represents their natural abundance. So notice here that the most common isotope is carbon-12, and the number is closest to that isotope. Here's a periodic table for your reference. You could probably guess what the most common isotope of nitrogen would be. It would be 14. The most common isotope of oxygen is 16. In fact, it's pretty close to exactly 16. And the most common isotope for hydrogen is hydrogen 1. All right, that's the end of the video. So please try to work your way through the rest of this activity and complete the check for understanding. Don't forget, the most important thing you can do for your success in chemistry is to practice problems. Reading and taking notes is only a very small part of your learning process. If you're reading and taking notes, you're not wasting your time, but your time is best spent doing as many problems as possible. All right, have a good day and good luck. Don't forget to check your work on the answer key.